Assalamualaikum and very good day. My name is Muhamad Nurhafizuddin Nadzmi, and I would like to present my dissertation 1 regarding the improvement of obstacle detection system of rolling stock for MRT Kajang Line. For my dissertation introduction, the local railway network boasts the highest passenger carrying capacity of any other form of public transportation. The number of train passengers in KL increased from 900,000 in 2018 to 1,400,000 in 2019. When the public transit use increases, the passenger safety must be the first concern. There are significant number of accidents that take place in railway industry, especially trespasser. Obstacle detection device, or as called as ODD, is a system created in order to detect whenever the train hit any obstacle on the track. The study titled The Improvement of Rolling Stock Obstacle Detection System for MRT Kajang Line will improve safety along the line's path. There are a few problem statements of this study. The first one is suicide attempt on the railway track, fatality to the passenger, train-to-train collision, damage to company's asset, and current ODD design do not prevent the train from hitting the obstacle. Then we proceed for objectives. The first one is to review the current obstacle detection device, or called as ODD, towards rail service reliability for MRT Kajang Line, to revise the design of obstacle detection device towards safety measure for rolling stock system, to prevent the impact of collision between train and obstacle along MRT Kajang Line alignment. Please owe me a few seconds to watch this video. These incidents happened in MRT Sungai Buloh Depot in 2021. As you can see, there is obstacle on the railway track. When the train is approaching, it doesn't stop and hit the obstacle. Because the current ODD design of MRT Kajang Line, the concept is hit first then detect. It does not prevent the train from hitting the obstacle. The scope and limitations of this study are: focus only on a straight track and will not take consideration at curve and gradient track. Practically test the detection method by using ultrasonic sensor and prototype model. Focus only on metro rolling stock, which is the maximum speed is 110 km per hour. The result will be based on prototype practical test. So the significance of this study will be divided into two, which are industry and community. For industry, reduce the impact and damage to the train, protect the company from huge loss, reduce the risk of bad company's reputation, ensure the improvement of ridership and revenue. For community, avoid suicide attempt and fatality, acquire the trust of passenger by offering safe rail services, encourage community to utilize the public transportation, and avoid trespasser collisions. For literature review, basically there are a few previous studies that have been added as reference for my study. The first one is State of Technologies for Intrusion and Obstacle Detection for Railroad Operations, which is written by Da Silva et al. Trespassing Railway Property and Topology of Risk Localities, which is the author is Pavlina et al. The Quality of Obstacle Distance Measurement Using Ultrasonic Sensor, which is written by Amin et al. The third previous studies is most similar with my study, which is the method is same by using ultrasonic sensor. So here are the other three previous studies that have been added in my improvement of obstacle detection method for MRT Kajang Line. First is obstacle detection for an autonomous robot, which is written by Rashid et al. The Train Central Control Unit, which is the CCU of MRT Kajang Line, which is prepared by Horst et al. And the last one is numerical and experimental study on the obstacle collision avoidance system using 2D LiDAR sensor. And all of these studies is regarding the obstacle detection method by using various types of sensor to detect the obstacle. For the methodology of this study, we start with the flowchart first. For review design and data collection, then we can proceed for improvise or redesign obstacle detection system and install mockup by using toy trains. Then after complete installation, we can proceed for trial run. If the trial run is not success, then we'll back to the redesign obstacle detection system and installation. If the try run is success, then we can proceed for evaluation. After evaluation, we can compile the result and make a discussion for the study. So in this slide, I'm going to explain the current method of obstacle detection device of MRT Kajang line, or we call it as ODD MRT Kajang line. As you can see, the diagram in the red circle, that is the location where the obstacle bar of MRT train is installed at the underneath of the car body frame. So that's why previously I stated that the MRT train ODD apply the concept of hit first then detect. I can say it is very inefficient because damage will occur whenever the train hit the obstacle. So the mechanism is when the train hit the obstacle bar will send the signal to the CCU. From CCU, it will send signal to OCC to trigger the maintenance team to clear the obstacle on the railway track. So now I'm gonna explain briefly regarding the proposed method of obstacle detection device for MRT Kajang line. Instead of using obstacle detection bar, we're gonna improve the method by using ultrasonic sensor. It will be installed at the end car of the train, and it is impossible for me to install at the MRT Kajang line train because it is not allowable for me to revise the design. But what I'm going to do is I'm going to install the ultrasonic sensor at the toy train to prove the effectiveness of the proposed method. So the ultrasonic sensor can detect the obstacle up to 30 centimeters. So this is the sketch or diagram of prototype. As what I mentioned previously, I'm going to use the toy train to prove the effectiveness. So the ultrasonic sensor will be installed at the end of the train. The toy train going to use the DC motor, which is controlled by Arduino microcontroller. The power supply is from battery. So then there will be a buzzer. Whenever the ultrasonic sensor detects the obstacle on the railway track, it will immediately stop the train and trigger the buzzer. Here are the components that I will use to construct the prototype or mockup. First is the Arduino Mega controller. The operating voltage is between 7 volt to 12 volt and the power supply is from battery. There are 16 input pins for the Arduino controller. It uses DC current. It is quite light. The weight is only 36 grams and I can install it on the toy trains. The RAM is small, it only 8 kilobytes. So the second component is ultrasonic sensor. As I stated just now, it will install at the end of the train. The operating voltage is 5 volts. There are 4 input pins. The range is 20 centimeters up to 400 centimeters. It depends on what type of ultrasonic sensors that I will use, and the frequency is 4 MHz. The toy train operating voltage is 6 volts. The weight is quite light, only 350 grams, and it uses DC motor. The other components for the mockup or prototype is relay. The trigger voltage is 5 volts, trigger current 70 milliamp. There are 5 pins of configuration. The operating time is 10 milliseconds and it capables up to 300 cycles per minute. So whenever the ultrasonic detects the obstacle, the Arduino Mega will operate the relay and cut off the power to DC motor. For buzzer, the operating voltage is 5 volts. It has 2 pins and the beep style is continuous. For battery, the supply voltage is 11.1 volt. It is rechargeable and the material is Li polymer. The expected result of this study, so there are 3. The first one, the current method of obstacle detection system of MRT Kajang line will be clearly identified. The effectiveness of obstacle detection system towards safety measure for rolling stock will be improved. The collision between train and obstacle along MRT Kajang line alignment, including main line and depot area, will be eliminated. That's all for my Dissertation 1 presentation. Thank you so much for hearing. Assalamualaikum.